Hello, everyone. Good evening, good morning, good afternoon from wherever you're joining us. I'm actually from Bulgaria right now, so good evening from me. My name is Dalia, and I work as a global community manager here at Kong, and I'm so happy to welcome all of you to our April Tech Talk. The topic for today is exposing services with the Kubernetes Gateway API, and we have Mattia, who introduced himself. I'm so happy to see so many of you here. Please post all of your questions in the Q&A function on the bottom, and we will answer them as soon as Mattia is done presenting. And with that, I'd like to pass it along to Mattia. Go ahead.
Thank you, Dalia. Hello, everybody. My name is Mattia Vacca, and I'm from Italy, and I'm a software engineer in the Kubernetes team at Kong. Kong is a company providing cloud connectivity. Today, we'll be talking about how to expose services outside the cluster boundaries with the Gateway API. Okay, first, let's take a look at today's agenda. Since the Gateway API is the successor of the Ingress API, we'll be briefly introducing the Ingress API as a first step. Then we'll discuss the Gateway API, its model, and the main resources to use for creating an effective Gateway API configuration. Last, we'll have a live demo with a couple of slides that will help us to understand the configuration. I bet many of you already know the Ingress API and might have been using it for many years, but regardless, let's introduce the API, the whys, pros, and cons, and see why the Gateway API has been designed and developed to be the next generation of Ingress API. So what does the Ingress API aim for? The main target of this API is to expose services outside the cluster boundaries without using a public IP for every single service we want to expose, as it would happen when using load balancer services. Then, with a single public IP address, we can expose different services. And this is the reason why the Ingress API has become a very widely used API for a very long time. Indeed, the Ingress API is GA, and shipped in the set of standard APIs of Kubernetes. Of course, it is not only, the Ingress API is only an API. Therefore, it needs an Ingress API implementation to be able to exploit the API and the whole feature set. An example of implementation is the Nginx Ingress Controller, which likely is the most adopted implementation. Here at Kong, we have our implementation as well, called the Kong Kubernetes Ingress Controller, or KIC. The Ingress API provides a good but not exhaustive set of features, among which are service forwarding, host and path matching, and TLS configuration. On the other hand, it has some limitations, such as the lack of certain features that led to the born of an implementation-specific annotations head. Last, the Ingress API wasn't designed to provide a sufficient permission model, and here is where the Gateway API comes in. As you can see in the draw, we have two main resources, the Ingress and the Ingress class. The Ingress itself defines the rules to route traffic toward the destination service. As we said, the Gateway API is the next generation of Kubernetes routing and load balancing APIs, and is in beta since July 2022. As the Ingress API needs an Ingress implementation, the Gateway API needs a Gateway implementation. Our previously mentioned Kong Kubernetes Ingress Controller has been improved to deal with the Gateway API as well, so that it is able to reconcile Ingress resources and Gateway resources at the same time. The feature set of the Gateway API has been massively improved, and a native mechanism has been provided to make the API extensible in a standardized way to avoid the annotations hell we mentioned before. The feature set of the Gateway API includes TLS configuration, as the Ingress API did, HTTP matching, which can be of different types, such as path matching, header matching, method matching, and query parameters matching. And then we have a couple of features that are bound together. Let's say they are related somehow, which is the possibility to reference some resources from other resources living in different namespaces. So basically, we have a native mechanism to grant cross namespace references. In this way, we can do cross namespace resource binding and traffic forwarding. Then we have the possibility to set HTTP filters to change the request and the response, the request of the response. For example, we have the request header modifier and the response header modifier and other filters. The request header modifier and the response header modifier are intended to be used to patch the set of headers to use for the request or the response. And last, the possibility to set weights on the routes to perform weight-based load balancing. Since the API is in beta since July 2022, many other features are under implementation. And yeah, there is still a lot of work to do to get GA. But the road is the good one. Again, if we look at the draw, we can see that an additional resource has been introduced. We have here the gateway class, very similar to the Ingress class, the HTTP route, similar to the Ingress. Indeed, it defines the matching rules and the filter, and the gateway. The concept of the gateway has been introduced in this API to represent a load balancer or a proxy. As we will see, we'll intend it as a data plane. The gateway defines multiple listeners and addresses. The Gateway API implements a multi-layer permission model and defines three different personas. The infrastructure provider is the top layer and is the person responsible for defining gateway class and managing the gateway control. He basically takes care of the user gateway API implementation. The cluster provider is the responsible for administrating the shared network infrastructure to be used by many different and non-coordinated teams. As you can see in the draw, it takes care of the gateway resource and all the resources related to the gateway, such as the TLS secrets, for example. And the application developers only needs to pull the wires to connect the services and export them. And this operation is performed by defining proper HTTP routes. Even if we only talked about the HTTP route, there is a bunch of other routes that can be used. Every route is supposed to use a different protocol and defines a different set of features. The Gateway API defines HTTP, gRPC, TLS, TCP, and UDP routes. So as you can see, both L7 and L4 routes are available. Last, the user can define their own routes using custom protocols to implement custom behaviors. As you can see in the slide, the only beta route is the HTTP route. All the other APIs are alpha, even though the gRPC route is hopefully getting to beta quite soon. Now, let's have a deeper look at the main Gateway API resources. The first one, as we saw, is the Gateway class. The Gateway class is a fairly simple resource. First of all, it is cluster-wide, a cluster-wide resource, which is quite important. And the main field of the gateway class is the controller name. Every gateway references a gateway class, and only the gateways using a specific gateway class are reconciled by the controller, matching the controller name field of the gateway class. In this way, we can have some gateways reconciled by the Kong Ingress Controller, for example, and some others by Contour, which is another implementation. Parameters ref is meant to be used for enriching the configuration of the gateways using this specific gateway class. One can specify group, which is this one, kind, and the name of a resource containing additional configuration. In the gateway operator case, for example, which is a project we will be talking about in a few minutes, the resource is named gateway configuration. Then we have the gateway, the resource that, as we saw before, aims at representing a data plane instance. The gateway is a namespace resource, and as you can see in this example, it lives in the namespace named namespace1. As we said for the gateway class, every gateway needs to reference a gateway class through the gateway class name field. Then we have the listeners field, where we can specify a set of listeners with a protocol and a port. And as we will see in a second, the listeners will be used by the routes to wire the internal services to the data plane. The listeners can be seen as a representation of the access points to the internal part of the cluster from the outside. As we saw before, the HTTP route is the resource to be used when pulling wires between the listener of a gateway and a service. The first notable field in this resources spec is the parameter. This field is the list of the gateways the HTTP route wants to connect to. They can live in different namespaces, but in this case, we need an additional resource, as we'll see in a minute. Then we have a set of matching rules. The matching can be of different types: path, header, method, and query parameters. Each of them has a different subset of parameters. As you can see in the example, we are setting a path matching of type path prefix. That means that all the paths having /hello as prefix match this rule. Last, the field backends references refers to the service on the other end of the wire we are pulling with the HTTP route. In this example, the service is in another namespace and uses port 8. Since the HTTP route and the service live in different namespaces, the Gateway API needs an additional resource to allow this cross namespace reference. And this is the resource. Here is the reference grant, which is a resource that aims at granting cross namespace references. And the resource of this example lives in the namespace named namespace2 and allows references from the HTTP routes in namespace1 to the service named hello service, living in namespace2. Without such an explicit grant, the configuration wouldn't work, and it would result in an error when trying to route traffic to the service living in the other namespace. Okay, now let's start with a demo. Okay. For this demo, we need 4 different terminals because we are going to perform some operations. And here we have some configuration files. And here it is, we can start. First of all, I would like to introduce a project, which is the Gateway Operator. The Gateway Operator is a project. Sorry. Okay. Is a project baked at Kong. It's a project in a tech preview state, so it's not production ready yet. It's kind of a new project that is getting traction, and it is quite focused on the Gateway API field. The Gateway Operator basically is a component, is a project that allows to reconcile gateway resources and to create control plane and data plane instances out of the gateways. So we will be using this operator to create our Gateway API configuration. We can see that our Gateway Operator has already been deployed in the namespace Kong system. And here is the controller manager with 2 different containers running. And along with this controller manager, along with this Gateway Operator controller manager, we have a bunch of CRDs that we can look. We have the control plane, the data plane, and the gateway configuration. We will understand how they work in a few seconds, in a few minutes. Okay, now, first of all, we need to create some deployment, some workload, because we want to expose this workload outside the cluster through a Gateway API configuration, right? So let's start with this first file. We want to create a new namespace named demo and 2 different workloads, 2 different deployments. The first one is called Bob, and the second one is called Alice. And both of them have the same container, which is this one, which is a fairly simple program that it is just an HTTP server that returns the current time. Okay, so Bob and Alice have the same container running, and they are exposed through two different services, cluster IP services, the Bob service and the Alice service, both in namespace D. So let's create these resources here. Sorry. Okay, I don't know what was happening. Okay, I just created Bob and Alice workloads, and we can see that we have our namespace named demo, which is 11 seconds old, and we can watch to all the pods and services in such a namespace. So we have Alice and Bob, and the Alice pod is exposed by the service Alice, and Bob the same by the service Bob. And so we just want to verify that all of them, that both Alice and Bob, are doing what we want them to do. So we just want to ping them, and we want to get back the current time, right? So let's open a stream for the Alice's logs. Okay, and let's do the same for Bob. Since the services are cluster IP and there is no external IP, there is no load balancer allocated for these two services, we have no means of accessing the deployments from outside the cluster, right? So we just need to port forward the traffic for Alice on port 8080 of my local machine. So if I curl Alice, so if I curl localhost on 8080, I see that I'm talking to Alice. And if I do the same with Bob, I should see the fact that I'm talking with Bob, right? Okay, so Alice and Bob are correctly set up, and we just want to be able to reach out to them from outside the cluster without forwarding all the traffic through kubectl. So as a first step, we need to create a gateway. And to create a gateway, we have three different resources. The first one is the gateway class, as we saw before. And the gateway class has a controller name, which is konghq.com/gateway operator, which is the name of the gateway operator controller. That is the component that will reconcile our gateway, and will be creating the control plane and the data plane out of it. And we have a parameters ref to enrich the control plane and data plane with additional configuration fields. You can see the gateway configuration here. We only have a field related to the control plane deployment options. And basically, we want to say that, okay, I want all the gateway APIs configured in the control plane. And to do so, we just need to enable the feature gates, the related feature gates, and to set the gateway alpha to true. And finally, we have the gateway. The gateway is in the namespace demo. It uses the gateway class named Kong, and it only exposes one listener with protocol HTTP and port 80. So let's create such resource here. Okay. And here we can look at the gateway. We can see that it is not ready yet because it's under provisioning. But if we look for other resources, such as the control plane and the data plane, which are resources that I showed before, which are CRD shipped by the gateway operator, we can see that we have one data plane and one control plane. The data plane is already ready, but the control plane is still under provisioning. So most likely we just need to wait for a little bit before having it ready. In the meantime, we can take a look at how the gateway operator works. Okay, so here is our scenario. We have the Kong gateway operator. We have the gateway that we just created, and the Kong gateway operator reconciled the gateway and created the control plane and the data plane instances. But what the control plane and the data plane are? The control plane is an instance of the Kong Ingress Controller that, as we saw before, it's a component that is natively compatible with both the Ingress API and the Gateway API. And the data plane is the API gateway shipped by Kong. It's basically the main product by Kong, from Kong, which is the Kong proxy. Out of the data plane, it's the Kong gateway operator will be creating, along with the Kong proxy, the proxy service, which is a load balancer service that is intended to be exposing the API gateway. So let's get back to our terminal and let's look. Okay, the control plane is provisioned and ready, and the data plane the same. So if we look at the pods in the demo namespace, we have one control plane, one data plane. Both of them are ready, so two different pods. And if we look for the services, we can see that a couple of services have been created. The first one is an headless service needed by the control plane to talk to the data plane, but we don't care about it. And the second one is the one that has interest for us, the data plane proxy, which is a load balancer service with an external IP assigned. So we can talk to this data plane, the API gateway, to Kong, to have our traffic routed according to our configuration. So basically, here we have another slide with the Kong Ingress Controller, the control plane that will reconcile all the routes, so HTTP route, gRPC route, and all the other routes, and will translate the definition of the routes into the set of rules understood by the API gateway, by Kong. And the data plane will be reached, and the traffic will be redirected to the correct final destination. Okay, so we have the gateway, we have the workloads, we have Alice and Bob in place. We just need an HTTP route because we need to wire our listener, our gateway listener, to the final destination, to the service, to the internal service. So here is the HTTP route. The HTTP route defines Kong as parameters. Kong is our gateway, so it will be attached to our gateway. And it defines also a set of rules. We have three different rules, 1, 2, and 3. The first one and the second one are very, very similar to each other. And basically what we want to do is perform both path and header matching at the same time. So basically we want to match the path /echo for both the rules. And we want to match the header person named Bob for this rule, and the other person with value Alice for this other rule. And as the backend ref, so which service to redirect our traffic, we have set Bob for our first rule and Alice for our first rule. So what we are expecting is that when we try to hit our data plane on /echo with this header set, the traffic will be forwarded to Bob or to Alice, depending on the value of the header. So, sorry, and there is this third rule, which we don't care about yet. We will get back to it in a few minutes. So let's apply our route. Okay, we just created the route. So we have our load balancer service, which is reachable at 172.18.11. So if we curl localhost 172.18.11/echo, we won't be hitting anything because I didn't set the header. I just wanted to show you the default message that the data plane Kong is getting back, is giving back when there is no route defined for the destination requested. So let's define the proper header with person named Alice. First of all, I want to open another string with Alice logs and the same for both. Okay. And okay. So now we are hitting Alice on /echo by setting the header person to Alice. And if we do the same with the header person set to Bob, we can see that we are hitting Bob as well. So we just managed to expose our internal services to different services outside the cluster boundaries by using a gateway reconciled by the gateway operator and an HTTP route reconciled by the control plane component of the gateway operator, which is the Kong Kubernetes Ingress Controller. Now I will get back to our HTTP route to the third rule, and this is the rule. The rule is quite similar to the previous ones because we want to still match /echo path with the other person set to Jack. So this is another person. But in this case, we have two different backend references. The first one is Jack1, the second one is Jack2. All of them live in a different namespace, which is demo2, because all our components now are living in namespace demo, but we want to hit Jack1 and Jack2 who live in namespace demo2. And we want to set also a way. So we want to have load balancing between Jack1 and Jack2. And we want to balance our traffic according to the weights that I've just specified here. So 1/3 requests roughly will be sent to Jack2, and 2/3 requests roughly again will be sent to Jack1. So the HTTP route has been already created because this configuration is in the same HTTP route I've already been creating. But we need to create Jack1 and Jack2 because we don't have such a workload yet in our cluster. So we have another namespace named demo2. We have deployment Jack1, deployment Jack2, Jack1 and Jack2 are the exact same component of Bob and Alice, so they are just simple HTTP server that reply with the current time. And we have two different services, service Jack1 and service Jack2, to expose the deployments in turn. So we don't have, again, load balancers. We just have a simple cluster IP service for Jack1 and the same for Jack2. So, oh, sorry. Let's create this resource. Okay, we have Jack1, Jack2. We can get the pod and the service in the demo2 namespace. We can see that the pods are running and the cluster IP services have been created. Okay. And now we just want to check that our HTTP route works as expected. So we would just want to check that from outside the cluster, we are able to talk to Jack1 and talk to Jack2. Then let's open another stream for Jack1 and the same for Jack2. And now we expect to set the header person to Jack and hit 172.18.1.1/echo. We are expected to hit either Jack1 or Jack2, right? But this is not working. And this is not working because, as you can see, indeed, the message is different. This is not working because Jack1 and Jack2 are workloads living in a different namespace, in a namespace which is different than the namespace in which the gateway and the HTTP route live. So basically, we want to cross the borders of the namespaces by using the HTTP route and the gateway. And this is not allowed by default. There is a proper resource to allow such a behavior, which is the reference grant that we mentioned before. And here is the reference grant that we want to use. It is called enable Jack. It lives in the namespace demo2. And what does this reference grant do? It basically allows all the HTTP route living in the namespace demo to reference as backend the services Jack1 and Jack2 living in the namespace in which the reference grant has been created, so demo2. Then we are expected to see the whole thing working just by deploying the reference grant. Here we are. The reference grant has been created. And now we are expected to hit either Jack1 or Jack2 by curling the endpoint. And here we are. We have just hit Jack1 a couple of times. Now, since we have set a load balancing configuration, so a set of weights on Jack1 and Jack2, we expect to see some traffic flowing toward Jack2 and some traffic flowing toward Jack1, right? So to verify this behavior, let's just set a watch on this curl so that we can perform the same curl every second, some second. And here you can see that we are hitting sometimes Jack1 and sometimes Jack2. Roughly, the proportion should be 1/3 requests should be sent to Jack2, and 2/3 requests should be sent to Jack1. So here is the configuration, which is completed. We have exposed our workloads outside the cluster boundaries by using the Gateway API. And we have performed some kind of matching. So we have performed the path matching and the header matching. And we also saw how to set up the weights on different routes to perform load balancing and cross namespace references by using the reference graph. So the demo is over. I would like to, before getting to the questions, I just would like to highlight here the some pointers. Here is the GitHub link to the Gateway API. Here is our link to the Gateway operator, which is this website. And the third one is the Kubernetes Ingress Controller. So basically, this is the control plane that we have been using in our demo. I just would like to say a few words about the Gateway API. The Gateway API is, of course, is a Kubernetes project. It's an open source, completely open source project. And as we saw, it's in beta since summer 2022, since July 2022. But there is this milestone, there is the roadmap to get into GA before KubeCon North America 2023. It's not guaranteed yet, but there is a milestone, there is a roadmap, and a lot of people are working on it. And so, yeah, it should be graduating for the KubeCon North America 2023. If any of you could be interested in the project or the API, feel free to reach out on Slack, the Kubernetes workspace, the Gateway API channel. And yeah, all the contributions are always very welcome. The community is awesome. Thank you.
Awesome. Thank you so much, Mattia. That was amazing. We have quite a lot of questions, so let's get started with those.
Yeah. When do you go for the Gateway API? When for the Kong Ingress Controller? I'm not sure I'm getting the question, honestly. The Gateway API is the API, as I said, and the Kong Ingress Controller is the implementation of the Gateway API. So basically, our Kong Ingress Controller is able to reconcile the Gateway API, and the Gateway API, as I said, is, I don't know what you mean when you say when, but the Gateway API is in beta right now, and the Kubernetes Ingress Controller is conformant with the beta implementation of the Gateway API at the moment. I have multiple clusters. Can I use the gateway across the clusters so that resources in cluster 1 are picked up by Kong in cluster 2? Yes, can use the gateway across the clusters so that the results in cluster 1 are picked up by Kong in cluster 2. Yes, you can do that by, well, not in a native way. Kong and the Kubernetes Kong Ingress Controller are not a multi-cluster implementation at the moment. But let's say that if you deal a bit with the API, if you handle a bit the endpoints, and you can create a configuration where you have one gateway in one cluster and the endpoint and the backends in another cluster, and you can manipulate the endpoints to redirect all the traffic toward a Kong instance in a second cluster. But this is kind of a manual configuration. By default, Kong Ingress Controllers and Kong don't provide this kind of situation, don't support this kind of situation. The code for this demo is not yet available on GitHub, but I will be making it available after the talk. What does the two items in dataplane do specifically? Proxy does is the proxy handler, and what does proxy service do? Okay, let's get back to the terminal. We have these two components. Okay, maybe you were talking about the slide. The slide here is the Kong proxy and the proxy service. The Kong proxy is the workload, basically. So it's the data plane instance, is the deployment of Kong that performs the routing and the load balancing. The proxy service is the load balancer service that, that exposes the data plane instance. So we have this data plane pod that is exposed by this data plane proxy service, which is a load balancer service. Other than Kong, what other implementations of the Kubernetes Gateway API are there? Well, there is a big number of implementations at the moment. We almost have 20 implementations, something like that. And it is getting a lot of traction. Many different companies are working on their implementation. Honestly, I don't remember all the implementation, but if you go to the Gateway API website, you can see all the implementations and all the implementers of the API. Does Gateway API support port-based routing as well? Yes, it supports port-based routing. It does. I'm not sure if it is a core feature or an extended feature at the moment. I should look at the specification of the API, but yes, it does. Then, can this be used across multiple clusters? Okay, I've already answered this one. How is this different from Istio Gateway API? Well, the Gateway API is an API. Okay, so basically there are many different implementations, but the implementations must be sticking to the Gateway API definition. So in the Gateway API, there are a set of conformance tests that all the implementations should be compliant with to claim that they are performant Gateway API implementation. So basically, what are the differences between Istio and our implementations? They should be kind of the same because there is no magic sauce. I mean, there is just the there's just the fact that every implementation must stick to the definition of the API. There is some differences between the Kong Ingress Controller, which is kind of the same of the Istio Gateway API implementation, and the Gateway Operator, which is another project at an higher level that help to provide control planes and data planes in a declarative manner. So the Gateway Operator is kind of a different project with different scope, and the Kubernetes Ingress Controller and Istio Gateway API or other implementations, doesn't matter, should be doing the same thing basically. What is the use case of this project? In what situation could it be implemented? Well, the use case could be, as we saw in the presentation, to expose services outside the cluster. What the Gateway Operator will help us to do is to do it in a managed and very easy way, without dealing with charts, complex configurations of the Kubernetes Ingress Controller and the API gateway. You just deploy a CR, in this case a gateway, or you can just deploy a control plane or a data plane, and the Gateway Operator will instantiate the control plane and the data plane. In the next iterations of the gateway control plane, of the gateway operator, we will be adding some features, such as, for example, the possibility to horizontally scale the data plane so that you can have many different data planes when you have tons and tons of different HTTP routes and many different backend services. So it is possible to perform scaling on the data plane to deal with huge amount of traffic. Could you explain again the wait rule? Yeah, yeah. Let's go. Let's get here. The wait. Sorry, the wait is the weight indeed of this portion of the route. So for this rule specifically, we have that we want to match this part of the specification, and we want to split the amount of traffic between Jack 1 and Jack 2. But we don't want to send all the traffic to Jack 1 or all the traffic to Jack 2, but we want to send a certain amount, to forward a certain amount of traffic to Jack 1, which is 2 in this case, and a certain amount of traffic to Jack 2, which is 1. How 1 and 2 have to be interpreted is that 2 is the number of requests that have to be forwarded to Jack 1 every the sum of 2 and 1. So just to sum up, we have 2 over 3 requests sent to Jack 1 and 1 over 3 requests sent to Jack 2. So you do the sum between 1 and 2, and 1 over 3 to Jack 1, 2 over 3 to Jack 1. Sorry, 1 over 3 to Jack 2, 2 over 3 to Jack 1. I hope it was clear. How is this different to the Nginx Ingress Controller? Well, when speaking about the Nginx Ingress Controller, again, they are just implementations. So the Nginx Ingress Controller is an implementation of the Ingress API, and the Kubernetes Ingress Controller is an implementation of the Ingress API, and both of them allow you to use the Ingress API to expose applications and to perform the kind of load balancing and matching rules that the Ingress API defines and allow to define. When it comes to the Gateway API, because Nginx has, as far as I remember, has its own Gateway API implementation, and Kong has its own implementation of the Gateway API. Again, they are just implementations. So since they are conformant implementers, they should do basically the same basic operations. If I want to implement authentication, then how we can configure it in Gateway? Yes, there is in Gateway, there is the possibility to set, to configure the TLS configuration. I didn't write it here, yeah, but it's part of the listeners field. So here you have the possibility to set the TLS configuration. You have the possibility to set the TLS mode, for example, pass through or terminate, and you have the possibility to set the TLS secret to use for authentication and encryption. So the portion of the API you're looking for is here, is in the under the listeners field. Do we have matches for multiple domains and feature to strip parts of HTTP route URI? Is the service expect a route at, say, Blesh? Okay, So if I'm getting correctly the question, you are saying, let's say that I have a match for slash and a match for slash something. If this is the case, there are three actually different ways of perform path matching, which are exact path matching, prefix, and regex. So if you are setting exact, only slash will be matching slash, only slash hello will be matching slash hello. On the prefix match, this is an implementation detail that should be verified in the API gateway, because in the data plane, this is kind of a corner situation. I'm not sure. We should test it. But of course, if you have slash and slash hello with prefix path matching, slash hello will hit both slash and slash hello. So yeah, I'm not sure about how the API gateway will behave in such a corner scenario. Is there a dashboard to visualize the matches services to proper plan? No, there is no dashboard to see it, and as far as I know, there is no plan to create such a dashboard, such a setup. Cross namespace isolation is bypassed using reference grant. Will it be open to all services, or where exactly in the path from client to pod does the check happen? Client gateway, HTTP route, reference grant, REST service pod. Okay, the reference grant allows you to cross the namespace boundaries when referencing an HTTP route. When referencing, sorry, a gateway from a HTTP route, living in different namespaces, and the same between HTTP route and services in different namespaces. And the check is performed by the Kubernetes Ingress Controller. So if this condition is not satisfied, the rules are not pushed to the data plane, so it is not possible to see our traffic routed toward the final destination, because the Kubernetes Ingress Controller doesn't convert the route to the proper set of rules for the data plane, because there is no the condition for the reference grant. And so the reference grant allows you to break the boundaries between HTTP route and service and HTTP route and gateway. Do you have body flags behind you? Yes, they are body flags. I don't know if Okong is hiring. Try to check it out on their website. Okay. Can this type of gateway API implementation support chain of responsibility microservice design pattern? I'm not sure what you mean by this question, honestly. I don't know. Honestly. Yes, the recording will be available later. Okay, I guess we are done with the questions.
Yeah, I think there is one or two more in the chat.
Okay.
Yeah, by Timothy and Yoda.
Why does the dataplane admin cluster AP service have no cluster AP? Yes, it has no cluster AP because it is headless service. So basically, if we We can look at it live. Service, dataplane. Services, demo, dataplane, Minkong. Okay. You can see that it has a cluster AP set to none. That it means that no endpoints are created for this service. So basically, you can just route traffic to the files to the pod referencing this service by using the full name, but there is no endpoint provided by the Kubernetes controller manager by on behalf of you. Okay, looking for other questions by. Okay, is HTTP streaming supported by the Kong gateway? Yes, it should be. Yes. Is the Kong gateway a load balancer? Example, can you have two instances of Jack1 and distribute traffic to each based on balancing rules? Yes, it is. It is. And this is what we just did. I mean, I had two different instances of Jack, and it was possible to perform load balancing between those two instances. So yes, it is. Okay.
I think that's all the questions. If anyone has any last questions, please ask them now. Oh, there's one more in the Q&A.
Yeah. I understand Kong uses a database for lookups. What performance impact is there, and what use cases are appropriate because of this? E.g., are there studies and performance metrics that can tell me what is the performance impact I can expect on round trips? Well, actually, the Kong has two different modes. There is the DB mode and DB-less mode. The DB mode is kind of the legacy mode, and DB-less mode is the newer mode of working of Kong. So for this demo, we just used Kong in a DB-less mode, and the Kong gateway operator only works with Kong in a DB-less mode. So there is no database for lookups in this scenario, in this demo. For what concerns the DB mode for Kong, I'm not sure if there are studies or performance impact studies on the performance, because I don't work in that team, but I guess so, and I think that they consider this issue. They investigated this issue for sure. Not related to the Gateway API, but are there any security concerns or notable changes switching from the old way of kick and proxy on the same pod and admin API only usable intrapod, the separate control and data plane, and the headless admin API service? Okay, I guess that you are referring to the new version of Kick, the 2.9, where we implemented the gateway discovery. And so, no, there shouldn't be any security concern in that configuration. And we also provided a way to switch between the old way and the new way. And yeah, it's in case that feature was huge to implement, was quite complex. And if you use Kick in production or for testing, and if you notice anything on any problem that you may notice, please let us know, because we are constantly looking for feedback to improve our projects.
All right, I think we're done. We're a little bit over time. Thank you so much, Mattia. There was a lot of questions. Thank you so much for answering all of them. And thank you to all of you who joined us today, who asked questions. It was a pleasure having you. You will all receive a recap email with the recording and some additional resources. We've already announced our next tech talk for the next month. It will be again on Ingress Controller. So you will see it in the email. You can register there. And yeah, I wish you all a good evening, good day, and I hope to see you next month at our next tech talk. Goodbye all.
Thank you.